All right, so for today, we're going to wind up starting our next chapter, which is going to be over linear equations, aka rate of change, aka slope. So, yay, new chapter. But this is also going to be the chapter that's going to lead us into our Thanksgiving break. So that's even more exciting, I feel like. Anyway, for day one, all right, we have what's called constant rate of change. So if y'all remember anything from 7th grade about constant rate of change, it wasn't super difficult to have to find it, but we do have to make sure we review it for 8th grade purposes. All right, so right here, if you look closely, definition here says constant rate of change describes one quantity, which is the y, depending on the other quantity, which is x, to move at a constant rate. It can be positive or negative linear relationship. How to tell if something has a constant rate of change? So these should look kind of familiar. First, you have to find the change in x's and then find the change in y's. So basically, whenever you're trying to find a change in something, all it's really asking you is, how did it change? How'd you go from one number to the next number? So in this case, for the x's, what did you do to go from 1 to 2? Hopefully you know, you just added 1. Then from 2 to 3, you just added 1 again. 3 to 4, you just added 1 again. Pretty simple start, okay? Now, as for the y, if you went from 7 to 14, whether you were adding or subtracting, what did you have to do to get from 7 to 14? Hopefully we know we had to add 7. Oops. There we go. To get from 7 to 14. Then from 14 to 21, add 7 more. Then from 21 to 28, add 7 more. Now, sometimes, all right, they will kind of skip around and try to confuse you and make it seem like they're not going at a constant rate. So they might do something like, they might ask you, what did you do to go from 1 to 3? Okay? If you went from 1 to 3 and you only had to add and subtract, that would just be adding 2, correct? Now, what if they said, what'd you do to go from 7 to 21? Then that would just be adding 14, okay? So whenever you go to kind of divide that and get your constant rate, it would really just come down to basically this stuff, okay? But anyway, I feel like I'm going ahead a little bit. I don't want to confuse y'all, so because this can be really easy, but it can also be confusing. All right, so once you figured out what they're going by, it says double check that each y and x value have the same change as the others. If they have the same change, then it is linear. All right, and if it is linear, then divide the y value by the x value. So this says change in y over change in x right here. Now, another way of seeing this, because sometimes they're not going to be nice and literally put the words change in y over change in x. They might just put a triangle that says change in y over change in x. So I want to make sure that we have that somewhere in the notes, okay? And then from there, boom, that's it. You found the constant rate of change. That's all you have to do. So in this case, if we have to put the change in y over the change in x, what would it say? Hopefully, since we know what this means now, our change in y was this plus 7, correct? So that's going to go on top as a positive 7 because it's adding. And then the change in x was up here, and it said we went by plus 1s, right? So that's going to be a 1. And since it was adding, that's going to be a positive 1. All right, so 7 over 1, that's it. Or if you divide this and just kind of put it in simplest form, then it's just 7. That is it. Now, that's if you have a table. So what if they put it in a graph? All right. So we have to pick 2 points, if not already picked, and travel from one point to the next with what's called rise over run. Now I know the word rise is written kind of incorrectly here, but the reason why is because they want you to be able to remember that your y's, okay, always have to go on top and your x's always have to go on bottom. So that's kind of like a helpful type of hint for you. Okay, so if we have a graph, here's our 2 points that they gave us. So we have to think about if the line is going up or down. So in other words, is it positive or is it negative? Okay, so how we can tell based on that is just like if you were reading a book, you always have to make sure you look from left to right, correct? So if I'm looking at this line right here, and I'm looking from left side to right side, then what does it look like it's doing? Does it look like it's going up, or does it look like it's kind of going down like some stairs? Okay, hopefully we know it looks like if we're looking from left to right, it's going down like you're going downstairs or downhill. All right, so we automatically know that this is going to be a negative rate of change, first of all. And then secondly, since we know that it's going to be a negative rate of change, then from there, it makes it a little bit easier to be able to find your answer, okay? So we're going to bunny hop and count the boxes, all right? So if we're going from this point to this point, all right, then we have to be able to bunny hop some boxes up and down, bunny hop some boxes left or right, okay? So here we go. If we're going from here to here, let's do left and right first, all right? So to go from this point down to this point, let's see how many boxes we had to go. 1, 2, 3, 4, 5. So we had to go to the right by 5. And then from here, if we have to go up or down, we had to go 1, 2, 3, 4 boxes down. And we're finally at the point. Okay, so what I described is exactly what's here. Put how many times you hopped up or down over the number of times you hopped left or right. Okay. So these were the amount of bunny hops that I did up and down, up or down. This was the amount of bunny hops that I did left or right, okay? Because we always have to make sure we do rise with the Y on top over the run, okay? And there's our answer, -4/5. So try these and we'll see what you get.